Okay, so we are back and let's continue. So, any questions on whatever we have done till now? Any doubts, anything? I can see that maybe two people got disconnected, I think. I think even I got disconnected and joined back. Okay, can you guys can still hear me, right? Okay, cool. I think I got disconnected in between and yeah, I just came back. So let's get started. Let me just remove this from the screen. And yeah, you guys can see the screen, right? Okay, cool. I think there's some issue with my network connectivity. If this happens again, then do let me know. I will switch my internet connection. I don't know what happened all of a sudden, but think it's I think it's stable now. But let me know just in case you see any kind of stuttering or if you are not able to hear me very well. Let me know at the same time. I will quickly switch back to a backup internet connection that I have here. Okay, so let's continue with the C sharp reflection. So now the reason why we did reflective DLL is because you can not only load reflective DLLs into local, into remote, but also local processes using the same technique that I shared earlier. But most of you might have know about execute assembly command, and I think that is something that is being used a lot these days. One of the things about execute assembly is that it's very different from your reflective loader. Unlike your reflective loader, which calls exported function from a DLL and loads it into memory, in case of C sharp or C sharp reflection, you write a simple code which starts your CLR or common language runtime, and that CLR simply allocates. You'll have to ask it to allocate some memory space for your P, load your P in that memory space, initialize any other DLLs that are required like ms core e or ms core lib.dll, and then execute your code from the very start. Now you can erase the MZ headers for this, similar to what you do for your PE as well. That's your reflective DLL. I would, however, not recommend doing that. I have had scenarios where, unlike your reflective loader, where you erase some headers, your MZ headers or your PE headers to avoid the usual detections. In case of C sharp reflections, if you go and modify that, there are times when your CLR.dll will actually require those erased headers to work. If you don't have those erased headers, then the C sharp loader by itself, not your loader, the loader that was written by Microsoft, that itself will have issues to find and parse the entry point from your for your P, and it will not work after that, or it will simply lead to a crash, which is not something that you might really want during a live engagement. So let's see what how these work, and how, if you want to load a C sharp into a target process, what needs to be done. So to get started, the first thing that we need to know is the difference between a managed code and unmanaged code. Managed code is anything that requires a virtual environment. You can also call your Python code or your Java code as managed code, because eventually your actual source code that you write, it is converted to a byte code. That byte code is passed on to an interpreter, which basically reads that up and executes that into memory. In reality, what you're simply doing is maybe it's as good as passing a script like a Python script to an exe, and that exe executes that. This is something similar to that, because when you take a look at the core of the actual unmanaged PE and the managed PE is going to be very, very different. Unmanaged code, on the other hand, is the raw or the native code that you write either in C, C++, assembly, or any compiled language, like for example, you have Go and so on. Because none of these programs actually require an interpreter to work, and they can run irrespective of, depending upon what you have written and what libraries you have present into the system, it will work on most if not all the systems that you have, which means that it can be cross compiled. You cannot say the same for managed code. Your managed code requires an interpreter to run, which in our case for CLR, for our C sharp code, it is going to be CLR, which uses just-in-time compilation, or what we call as JIT, and it uses the VES from Microsoft, that is virtual execution system, to read up a PE into memory and execute that directly. Managed code over here will always be converted to bytecode before execution, and it is passed on to your CLR itself. The Microsoft runtime assembler is required to compile it during runtime and execute that. And it is as simple as that, basically. One of the things which is pretty important during C sharp execution is app domain. App domain is one of the core, I would say, point where most of the executables get detected, because when you use something like ETW, and if you don't patch your, or if you don't modify your app domains, or if you don't patch your ETW TI, then sorry, not the TI, my bad, the ETW event right, it will be able to read your assembly names. And if you're loading something like like seatbelt or Rubius, the assembly names that you use will be easily readable by your ETW, which can directly perform a string comparison and kill your process. That is what almost all EDRs currently do till date, and that is why you're running something like that is why you always patch ETW or AMSI before running something. In case of seatbelt or Rubius, you will have the exact same naming convention of seatbelt and Rubius, and no matter what the EDRs say, all of these are nothing but ETW based string comparison based detections, which means there is no heuristic detections that are being performed. Even though there are heuristic detections, but they're not towards anything else apart from strings, which means the moment you, let's say, you go and modify a C sharp code, you go and run it again, then the strings that you have in your PE will be different and it will not be detectable. That's what most of the YARA rules are built on. One of the most funny things that I used to do in my when I was basically in Mandiant doing like a ton of red team assessment was to download whatever open source tool I want to run. I would recompile the whole source code, because at that point of time I did not knew about ETW, and that was still not a thing, that is patching your ETW event right. So what we used to do, or specifically I used to do, was to download everything, change all the function names, assembly names, the GUID that would be present in the project, recompile it, and run it even without patching AMSI or ETW in the specific case. That was one of the best things that I always did, because you are not patching AMSI, you are not patching ETW. So you don't have to worry about, let's say, any possible suspicious detections which can detect your AMSI or ETW patching. Now, I have not seen a single EDR which detects ETW patching or AMSI patching, but again, that is just still an example that can be done. And that's what I always did for my .NET 4 based executable. Same thing for my PowerShell code as well. However, you can also go ahead and change some portions of that with custom app domains. So make sure your app domains are different. I will take a look at how we can modify our app domain names as well if required. And your app domains are also used, or the core logic behind using app domain is that you can run multiple C sharp files into a single process without killing it and starting it over and over again. And you can load multiple C sharp executables in the same code into different app domains and run them at the same time. This is something that your CLR does to load multiple DLLs or C sharp EXEs into a process and run them simultaneously. Just one thing that you have to be wary about is that the more number of C sharp DLLs you will have in memory, the more number of RWX regions you will have in memory. There is no way you can evade it because these allocations are not performed by virtual alloc or by you. These allocations are allocated by an API called as heap alloc, and using heap alloc you can allocate RWX regions. And since the PE recompiles itself during runtime and extracts some required values, these are always allocated as R, W, and X regions by your CLR. The best example for this can be taken a look at by just opening something as simple as PowerShell, going over here and taking your PowerShell assemblies. So if you go here and if you take a look at the .NET assemblies, you will see that the app domain is the default app domain. You will see it uses the Microsoft.PowerShell.ps read line, which is basically specifying the sorry, my bad. This is specifying which required DLLs were loaded into the app domain. And if you go to the memory section and if you scroll down, you will see the tons and tons of memory regions over here, the RWX regions. And if you open this up, you will see some of these are garbage, which are nothing but your executable sections. Some of these are just raw values over here, which are not being used. But these modify during runtime when you actually load the CLR. So these values over here will change eventually. And that is one of the reasons why CLRs will always be allocated in RWX regions. This is always done by your CLR.dll that you see over here. A few DLLs which are very important in this specific part is one is the version DLL, which you should see. Yeah, one is the version.dll, which is required for loading your CLR files. You have the CLR.dll, CLRjit.dll, and then you have the let me scroll over here. There should be another mscore or mscorelib.dll. Yes, mscorelib.dll, mscorelib.ni.dll, and mscore.dll. Now, these DLLs are responsible for your loading your .NET code in actually. Anyone knows what mscorelib.ni.dll is used for apart from mscore? Any guesses? Anyone? Just in time, yes, and it is also responsible for calling your native code in the backend. Whenever you try to call any native code directly from your C sharp code, like for example, you're going to call any NT API by directly extracting the function pointers. So your mscorelib.ni.dll is responsible for converting your raw code, whatever you specify, to a native code in the backend before it eventually goes to call the syscall in reality. So that is one of the main reasons why you have mscorelib.ni.dll. And that is also the reason why having C sharp code is pretty important because, or basically, it is not that easily detectable unless until you modify your .NET assemblies. If you modify them, .NET assemblies, if you modify the strings and the function names, you won't have to worry about most of the detections over here. But however, we will take a look at how to load our, what do we say as the C sharp in memory, and we'll see how we can patch ETW and AMSI at the same time. So going back to our code, this is what we are going to do. We are going to take up this sample over here uh, from Lee Christenen. I think he was the original author of Unmanaged PowerShell. And over here, the core logic, the core of the PowerShell loader that we have is split into three parts. Now, just because it loads PowerShell, don't think that it just loads PowerShell, because the core logic over here, or what it does, is that you have a C++ code. The C++ code contains a header file. That header file contains bytecode for your DLL that was compiled in C sharp. Now, this C sharp DLL that was compiled, that is responsible for loading your PowerShell scripts, which means that if instead of this C sharp DLL file that loads PowerShell, if you supply a seatbelt file and you embed that inside over here, your C++ file will load that C sharp executable and run it in memory. So basically, in the end, you are either calling a C sharp code to load your PowerShell and return you the output, or you're calling a C sharp code directly and getting you the output that is required. So this is how it is done. Let me directly go back to the code itself so that I can explain it better. I'll go to unmanaged PowerShell. As you can see, there were two repositories which were loaded. One is the PowerShell runner, and the other one is unmanaged PowerShell over here. So we're not a lot interested in PowerShell runner because I'll tell you why. If you take a look at this code, unmanaged PowerShell, it has the unmanaged PowerShell.cpp, and then it has the PowerShell runner.dll. Can anyone tell me what this looks like? Any guesses? Any guesses what this is an output from which tool? Yes, it's a PE file, correct. It's not, it's a DLL, not a reflective DLL though. It is basically a PE file. But any guesses what this is an output from? From which specific code? Hex dump? Yeah, I was more talking on the basis of from how did you get the output. So xxd command. So basically when you perform an xxd command on, yeah, xxd, when you perform an xxd command on a PE file, it converts the PE file into bytecode. You can see the MZ header over here. If you scroll down, you should also be see the P header over here somewhere. And at the bottom over here, you should find the total size of the PowerShell runner DLL over here. That is basically the length over here. Now we go back to PowerShell.cpp. So this PowerShell runner.dll, let me pin it over here. This is the hex dump from your PowerShell runner.cs file. And you can see this is basically a C# code. And this C# code that you have over here, this was written by Lee Kristen from the place where I extracted this PowerShell code. And what it simply does is that it takes the PowerShell string, whatever you pass it across, runs that and returns you an output. So I'm not a really big fan of the C# code, so we won't be going through this because this is just responsible for loading your PowerShell code. However, what we will be going is once you get a DL, when you compile this CS file, let's say I right click on build, it compiles the CS file for you into a DLL file. We will perform an xxd command on this DLL, which we will copy and paste inside our header file. Now this header file is nothing but our C# DLL. Remember that C# DLL is different from reflective DLL. Reflective DLL is what you have as a unmanaged code, whereas your C# is your managed code. So instead of this, if you add your seatbelt code over here, then it would basically run seatbelt in this case. So in short, we are going to write a C++ code, and this C++ code is going to load our buffer that we have in memory, similar to how we loaded the reflective DLL by reading it from disk using create file API call. Once we load this in memory, we are going to initialize the CLR DLLs and then call its entry point. It's not really that complicated, even though it looks like a lot of code. So let me quickly explain it. Sorry, my bad. Let me. Okay. So let me just unpin this. I don't think there's an option to unpin this. Never mind. So let me go back to our int main where we start. Okay. This is where our code starts. And if you see these errors, they are totally fine. That is what the Visual Studio is acts a bit stupid at times. So you can totally ignore this portion over here that you see. One sec. My bad. Yeah, I for some reason it just give me a sec. Where did the I think my DM is acting a bit weird. Never mind. I'll just keep it as it is. So it's totally fine if you see these values over here that it shows as identifier is undefined because they are actually linked during runtime from your MS corelib DLL. So it's totally fine if you see something like this. So let me explain what we are doing. We have our iCore runtime host. Now your iCore runtime host that you have over here, it is responsible. It is basically a COM interface, your DCOM kind of thing. And this interface is actually responsible to provide different types of methods to enable. When I say method, they are basically functions. It's a C++ class, I would say. They're not exactly a class. It should probably be called as interface itself. It's an interface which is responsible for providing you options to enable, disable, modify how your app domains look like, or how to load DLLs into memory. Only for C# DLLs, not any other DLL. we're going to create a simple pointer which will point to our app domain later on, and our default app domain over here as well. I'll come to this part when we start utilizing it. Over here, you can see I have provided the .NET assembly name to load over here in this case, which is called as seatbelt. And one sec, this should be PowerShell runner. Give me a sec. This should not be seatbelt. Uh, one sec, let me run this. I think, let me see whether this runs. Think I might have the wrong code repository. So just let me see if this runs. If not, I'll share you a different one. And it's PowerShell. No, it would be in the bin file, the DLL. Yeah, let me see. Yes, this is incorrect. My bad. Let me see what is the entry point over here. Because over here, yeah, let me just go ahead and show you how this can be modified. So over here, you have to specify your assembly name. This is the assembly name that you usually see over here. Sorry, my PowerShell is dead. But normally in the .NET assemblies that you see, this should be the assembly name that we have. In case of our code, you can see the assembly name that we have is PowerShell. Class name is PowerShell runner, and our assembly name is also going to be PowerShell runner itself. So I will just copy this. I will go here and I will replace it over here. PowerShell runner dot PowerShell runner. The reason for that is because our namespace and our class that is going to be our assembly name later on, both of them are the same. Let me just compile and see whether this works or whether I have made any further changes over here. So just bear with me and let me see. Okay, this is new. One sec. Might have provided the incorrect code. Give me a sec. Let me just go through this code. We have PowerShell runner, PowerShell runner over here, and the same. I think we are not executing something. So basically we have the assembly name, we are creating the class name over here, which is also the same name. Once we initialize the class name, we go and enable the core runtime host by calling create host. Create host over here calls, it first tries to call create .NET 4 host if it is present. If it is not present, then it will go ahead and call the create .NET 2 host that we have. In the create .NET 4 host, what it does over here, let me just scroll up. As you can see, it takes a handle to msquery.dll. This msquery is basically extracted by calling load library and extracting the address using get module handle, which you should see over here before we actually call it. So let me scroll up. Yeah, over here you can see we are calling create host. Inside create host, you can see we are calling load library over here, getting the handle and passing on the handle over here. The version over here, by default, we are asking it to load the version which was yeah, v4 over here, and we are simply specifying a pointer to our core runtime host, which will be initialized by our create host. Our create host forwards our pointer to the iCore runtime host and the version that we have after initializing the msquery.dll, and it passes on that to .NET 4 or .NET 2, depending upon what you have present in your system. The .NET 4 host that we have, it takes the handle for MS query, tries to find the CLR create instance function pointer. If it is able to find, it will basically call that will with the CLSID. CLSID is your type interface, which is basically used for COM initializations. Now this type interface along with the pointer to our meta host will be used, which is basically empty, and it will call CLR create instance. So it should create the type interface for this and should initialize an instance for your .NET Core runtime and put that pointer for that initialized core runtime over here. Remember that your core runtime is responsible for loading everything. Once we initialize this meta host that we have, we'll try to get which runtime is currently installed. If 4.0.3019 is installed, we will return that over here. If it is not, then we'll go ahead and try to load the v2.0 over here. We'll go ahead and see whether it is still loadable over here by calling the core runtime, that is v4.0. If it is there, we'll go ahead and load that. Else, we'll go ahead and try to initialize the core v2.0 runtime over here. We will return whether it's true or not false, depending upon that. If we reach till here, which means we have not jumped directly to cleanup. If we have not jumped directly to cleanup, it means it is true. And if it's true, it means your .NET Core runtime was initialized. In your .NET 2 runtime, if for example, let's say you did not have .NET 4 at all, then you will, over here, if you did not have .NET 4 at all, then you will do the exact same thing over here and directly try to initialize the core bind to runtime. Unlike over here where we called CLR create instance. CLR create instance is only there in .NET 4, whereas .NET 2 requires you to call core bind runtime. Now both of these are nothing but simple function pointers that are required to initialize your CLR.dll into memory. When you load msquery.dll, this CLR function pointers that you're going to call, this is responsible for loading your msquery.ni.dll, CLR.dll, instantiating its host so that its interpreter can actually go ahead and load your C# code that you have in memory. So once we initialize this specific value from our create host function, we will return whether it was created or not, true or false. Once we receive that over here, we will go ahead and ask it to start the runtime host over here. Then now this runtime host is basically what calls your application frame host in the backend. That application frame host.exe, which is what you normally see over here, application frame host. This is responsible for initializing any or performing any communications between two app domains or loading your CLR.dlls and running them into memory. This should never be terminated most of the time. So now when you start this, the next portion that we have to do is to initialize our app domain. First, we go ahead and get the default app domain that we have over here. We will get that default app domain if once we initialize it inside this specific pointer. We will go inside this thunk and check if there are any default app domains by default present for this specific IID. If it is present, we will get a pointer to this default app domain for the current assembly that we have initialized. Now, once everything else is ready, the only thing that we need to do is to load our assembly that we have in memory, that is PowerShell runner DLL, and execute it. In order for this to run, we will first create a simple array. Now, what we are doing over here in the backend, it is somewhat similar to what you call as virtual alloc. But the memory region directly allocated by virtual alloc cannot run over here. So we are directly going to ask our CLR to initialize all of that for it. And we're just going to simply create a structure, copy our values that we have inside that structure. And when I say these values, it means your any arguments that you provide, any CLR, any DLLs that you want to load, and its size as well. So we'll initialize this bound structure. We'll specify what is the size of this specific DLL that we are going to load. We will initialize our L bound values with 0, where it should basically stop for our PowerShell DNL runner. We'll create a safe array. Safe array is basically nothing but a normal array where you're going to copy your whole DLL to. This array will be used by your CLR to copy it to an executable region and execute it over there. So we're going to initialize this array by copying our DLL over here. Unlike in our C code where you normally call memcpy on heap allocate region, we are doing the exact same thing, but it is in C right now. It is in C++ right now. So we'll lock it so that no one modifies it, because if someone else is trying to modify, normally this should not be an issue, but you should always lock it before initializing as per the Microsoft documentation. We lock it, we copy our DLL over there, we unlock it so that it can be used by anything else. We call load3 on this assembly PowerShell runner underscore DLL that we had copied over here, and the total length of the DLL. And I think I realized what I did a mistake over here is that this is not the PowerShell runner's DLL, and this is why it was not running right now. So just give me a sec and let me just copy this DLL that we have, because I can see over here that the size of this DLL runner.h file that we have is this, and the PowerShell DLL runner's size is never that big. So let me go here to, yeah, sorry, not over here. Let me see where it was. Yeah, it's over here. And you can see it's only 14 kilobytes in total. That is our PowerShell runner.dll. So what I am going to do is I will need to convert this code that I have. Give me a sec, because this is my virtual machine. So let me go back to my base system. Just hold on for a sec. Day 2, unmanaged PowerShell. Okay, we have over here. And now we need to go into this repository. I'll share the updated code. Don't worry on that. Yes, it was seatbelt. Yes, it was seatbelt over here. So in one, I think in one of my previous, I forgot to change the source code where I took the demo of this last time in my previous workshop. So I'll go to unmanaged PowerShell, and I'll tell you the reason why it was not working as well, because I have. Let me go back. I've specified the entry point over here for PowerShell runner, which is basically of my C# code namespace and entry point. But I'm trying to call this inside my seatbelt code, which obviously will not run because seatbelt has its own namespace and class entry point as well. So that is why it was not running. I'll show you how that can be run as well. But right now, in order for it to run, I have to convert this xxd -i PowerShell runner.dll. Sorry, I think I'm in the wrong directory. Okay. Yeah, I'm in the, I have to go to the bin. Sorry, which directory I'm in already? My bad. I think I'm in the wrong place. My bad. CD unmanaged PowerShell ls cd. There should be another directory called as PowerShell runner. Why can I not see the PowerShell runner directory? I think I'm in the sec cd temp. Yeah, my bad. Wrong directory again. Day 2 unmanaged PowerShell. Yeah, the PowerShell runner directory was not present. What you see over here, I was in a different directory over here. I was in my backup code directory, so just bear with me. Too many directories. Yeah, we have it over here right now. Unmanaged PowerShell and debug. Oh, sorry, my bad. Day 2 unmanaged PowerShell. This should be PowerShell runner. Yes, PowerShell runner. My bad. So here, bin debug. Yes, this is the file xxd-i PowerShell and I'll just type something like, for example, let me see what is the name. Let me just type, let's say, psrunner.h. We will rename it later on, and you can see we have this file. Control X. I will go back and copy this to my unmanaged PowerShell code. I will rename. I'll delete this because I'm going to rename it with my code that I have over here. And I think by default Visual Studio does not update unless you close and start it, because we modified it on disk, so I have to start it again. And let me see whether we have our updated file here. Yes, you can see 13 kilobyte right now. That is basically our PowerShell under CSDLL. Now let me compile and see whether it works. Yeah, I think my function names are different. PowerShell runner, let me build, clean, and build. I think it's compiling a different thing. Right click, build. What is the error? PowerShell runner.dll redefinition. Should not have a redefinition. Included this file over here, right? Yeah. Okay. Visual Studio is just stupid sometimes. So yeah, let me close all of this, and now hopefully it should work. And something happened. Give me a sec. Let me see what happened over here. So running the argument. Yes, we did not provide any argument for it to run. My bad. I should have read this over here. So let me type PS, let's say echo $ps version table. Yeah, as you can see, it's running PowerShell right now properly. So if I try something else, let's say for example, get hyphen process. I don't need double quotes actually if I'm typing a single command. And you can see it basically ran the whole PowerShell code and gave me an output over here. So basically what we actually did was there was a minor mistake that instead of having this so basically you have this CS file which loads your PowerShell and runs it using .NET assemblies. We converted this DLL, we compiled this to a DLL, we created the hex output of that DLL, copied over here, and using this copied DLL that we have over here, we loaded this bytecode that we have inside our basically created an memory over here, copied our DLL over there, loaded that into assembly, and simply called invoke over here. And before I did that, let me just comment this out because this is not being used right now. Over here, what we are simply doing is I call load to load our array file, which contains our PowerShell runner dll.h. Once we call that, we are extracting the class name because we want to run this class that we have. If you have multiple classes, you can actually invoke multiple classes together as well if required. Currently, we are just going to instantiate the class name that we initialized over here. Namespace dot class name, similar to what we have, namespace dot class name that we have. Now, once we have initialized the namespace dot class name over here, the final thing that we need to do is to call invoke method. The invoke method is a custom function. I will come to this part in a sec. I'm going to pass on the initialized interface that we have created. I'm going to ask it to call the invoke ps method inside our class name. You can see we have invoke ps method inside our class name, inside our namespace, and that's what we are actually calling. And whatever argument the user has supplied, we will pass on to this invoke method that we have. Once we pass this along over here, yeah, so normally actually this should have been something like, for example, this argument over here, and yeah, that's what I was expecting it to run at the very start, which it did not run because I provided the same arguments. So in short, what I was doing was that if the user does not provide any argument, it runs this simple car string. If the user provides an argument, it will simply go and run that argument that the user has provided over here. So if I compile and run this, sorry, I should compile it over here, because by default when I call compile, it normally sometimes compiles the PowerShell runner. And I run this. By default, if I don't specify anything, it should run, as you can see, it runs this. If provide an argument, it will simply go ahead and run that argument that you have over here. Now, once you have run this, let's go back to invoke method. We have the type interface pointer for what we initialized for our core runtime host, which contains our .NET assembly and all those structures. We have our method that we want to execute, which is invoke ps from our C# code that we have over here. And finally, we have the argument that we want to run. Now, before we call this method, we have to convert this argument into something that this code will read. And you can see it requires a data type or basically of string. Now, remember that this is different for every code that you compile. If you quickly open up, let's say, seat belt, and open up the seatbelt code, sorry, not the seatbelt. It will show me the images of 10th of seatbelt on Google. So if I go to seatbelt, let's see what we have. Program.cs, that should contain the entry point, and you can see the difference over here that we have. Let me go back here. You can see we have the namespace as PowerShell runner, which is different over here. The namespace is seatbelt itself. Then we have the class name, which is also a bit different because you can see we have a public class over here, whereas we have a public class, static class here. And then the entry point over here is a public static string invoke ps, whereas over here it is public static void. And another different thing over here is that over here we're just passing on a command, which means the invoke ps takes up any command that we have passed on and runs that command over here. Unlike the seed belt, where it takes an argument of an basically an array of which contains multiple arguments, and basically it will parse that and run that. And the reason why this is different is because over here we are actually running our PowerShell code. So whatever PowerShell code that you supply, you can literally supply an argument of your power view.ps1 semicolon, and then you can supply whatever code that you want to run, maybe like import module or whatever you want to do, and it will run that value over here. So if you have a large script, just copy your large script inside a car variable, or maybe read it from disk, add a semicolon and add whatever code you want to run from that specific imported file, and it would run that command over here. We cannot do the same thing for our seat belt, however. As you can see, it accepts let's say an array of strings. In such scenarios, you would need to convert whatever command that you have received into an array of strings. In our case, we are doing exactly opposite over here. We are taking whatever argument that we have supplied, creating a safe array where we will be copying this argument over here, because this requires a method of type of class string, and that's what we are going to convert our simple wcar string into. Once we get that, we create a vector. Now what vector contains over here is that it can create an array of different arguments, different argument types. In our case, it's just going to be a single string over here. However, we are going to supply variant, which means it can contain various different types of argument type over here. We're going to initialize our argument that we have created over here with index value as 0, because we are only going to supply one single argument, and we are going to initialize our variant that we have created with the argument that we supplied. If this is more than 1, remember, if this value is more than one single string, maybe a kind of a array, for example, like multiple different commands for seatbelt, we will have to change this index value over here. Now, once we go ahead and initialize this, we'll go ahead and call invoke member 3 from this SP type. Now, this invoke member 3 is a type interface created by Microsoft inside the type PTR array. Whenever you call invoke member 3, it will take whatever your static method name is, call this method that you have, which is going to be our invoke PS method. It will now the binding flags will always be this for your C#.NET code to be called. We'll go ahead and pass on our argument pointers that we have initialized over here. And finally, we will wait for a response over here. You can see we have a invoke return val, which basically captures whatever the return value over here in this case would be. In our case, it's going to be a string value, as you can see, and we should have our invoke string VTPS invoke return val as a random value. Now, this is totally dynamic in nature, which means irrespective of whether you return string, word, dword, integer, pointer, or something else, it will get exactly that. Once we have that, we are just going to print it on screen, which is what we did our get process output that we have. Finally, we clean up the strings and then we simply exit over here. I know that this can be a bit confusing, so let me know if you want me to explain this again. Is it? I've tried to make it as simple as possible in the slide decks over here. As you can see, the .NET code that we're going to run, this .NET code is compiled to a DLL. This DLL embedded is basically going to get called from your unmanaged PowerShell. We simply load our CLR, either 2 or 4.0, depending upon which one we have. Initiate our app domain, as you can see over here, and start our core runtime, which loads our CLR.dll and other DLLs or the host required for the .NET code to run. We get the default app domain that is required for this code to run. We're not creating any custom app domains. Once we do that, this is our PowerShell runner.code, and we are going to copy our PowerShell runner.dll, which is in a hex format, to a safe array. Then we are going to call load3 on that safe array to load it into the app domain that we have created. We're going to instantiate or extract the class name that is going to be PowerShell runner, which, if you remember, we exactly loaded over here the assembly name and the assembly name dot class name that we have. Once we did that, we will take whatever argument you have, pass the argument over here, or a user supplied argument, whatever that would be, and we're going to call the invoke method over here, invoke PS method that we have. So basically, assembly name PowerShell.runner dot your class name dot your invoke PS that we have, and finally we basically executed in this specific portion. Is this understandable, by the way? The whole core or the logic behind this? Okay. Anyone else? Any doubts? Any questions? Confusing but understandable. That those are totally two opposite things. But yeah, I can explain this again if you want. And coming back to Lenny's question, argument passing is a bit confusing, but we'll check on it on the code later. So the argument passing over here, we're just specifying a single argument. You can see that it's just one argument, a single string, not a array. You're passing that single argument as a single string, whatever, like you, for example, something like this, get hyphen process over here. Sorry, my bad. Get hyphen process, that's what we are passing it across. Now, since this is a single string, we have to specify the index for this string. Since it's a single string that we have, we're going to specify it as 0. If, for example, we have something like, for example, let's say if you're going to run seed belt, then, and we have something like, let's say get hyphen, let's say for example, get hyphen process, and then we have maybe, let's say, another argument that you need to pass across, let's say test or whatever that would be. For example, in case of seed belt, it would be, let's say, maybe system over here, the command that you pass on, maybe let's say a host name that you want to pass on, or anything else for a matter. Then since if you're going to pass two different values, then this would be something like, for example, wcar, let's say args equal to this, and this is how we are going to have it as over here. When you have something like this, for example, with two, sorry, my bad, let me write a semicolon. So when you have something like this, these are two different values over here. Then we'll have to initialize this by 1. 1 basically means 0 and 1, two indexes for two different values over here. Does that make sense? And by default, then we'll go ahead and initialize each of these values. Is this clear how what we are doing? Okay, cool. I think this will be a bit more clearer when we talk about loading directly seatbelt into memory, because this is different from seatbelt. Currently, we are just running a PowerShell.cs code with an entry point called as invoke PS. But the catch here is that whenever you try to run something like seatbelt or Ruby's, they won't have invoke PS as the entry point or these class. All of them will have a common namespace, a program name, and a main method that you have over here. Our main logic over here that we need is basically program and main. This should be common. If this is different, that can be a bit problematic for us. I'll show you how that can be done. But is the remaining part over here clear? What is being done? Apart from the argument array part, I'll come to this part again when we talk about seatbelt. So don't worry on that part. This one, right? Yes. Don't worry on that. We will take a look at how this can also be taken a look at. And let me do one thing. Let me actually add a sleep over here to show you how this actually looks like in memory. I forgot why the sleep was there. So it's a 20-second sleep so that we can actually take a look at our code. Let's say I run this. I'll go here, search for my unmanaged PowerShell. And let's take a look at .NET assemblies. Can you see over here app domain colon default app domain that we have? You can see the PowerShell runner, the assembly name that we have. This is what makes it suspicious. So when you have something like, for example, seatbelt over here, this namespace, that namespace will show up over here, which is what your, and all these .NET assemblies are tracked by your ETW. If you patch ETW, this won't show up over here. Is that clear? Okay. Cool. So now what I'll do is, yes, Nick, I was just about to go to that specific code itself to, let me just open up the other code that I have. I was actually going to give that as a task, but considering this might be a bit complicated, let me share the task directly because I think that might be a bit complicated for today to get started with. So give me a second. Let me just share the code here. Sorry, my bad. Just give me a sec. I've shared a C# loader.zip file right now into the Discord channel. I will close this and copy my C# loader. Give me a sec. I'm copying that in my base VM. And we have the C# loader file and a simple SLN file that we have. So this should clear up a lot of things, including your ETW question regarding this. Okay. So as you can see, we have a header file which contains seatbelt.exe here. The size of seatbelt. This seatbelt.exe was directly extracted by downloading this seatbelt.cs file. So, sorry, by downloading this seatbelt repository and compiling this seatbelt.exe that you get over here when you compile this. I called a xxd on this seatbelt.exe, and yeah, I just give me a sec. I think I'll just also share the code that I just modified for PowerShell so that I don't forget it. Give me a sec, because the one that I shared earlier at morning, I don't think that would run. I think it is containing a lot of garbage. So just give me a sec while I clean up the compiled stuff and just build, clean. Okay, perfect. Else the Discord channel will not allow me to share all of these. Okay, it is still a lot larger than I expected. One sec. Let me just clean up the VS folder. Unmanaged PowerShell. Delete. Compress and send it across. Yeah, this is much better. Only 1 MB. Okay. So this code should work for you. And I will go back to our C# code that we have. So this is basically seatbelt.exe, which I downloaded from directly over here. From Harmjoy, we'll go back here and let's see what we have over here. Now this looks a bit different. Let's see what we have. I have a commented code here, which extracts ETW event write from ntdll.dll, returns me the address. I call page read write on this, write it with our patch bytes. You can see this patch byte 0xc3. C3 simply returns is called as ret. This is the opcode for 0xc3 and empty null bytes after this. We also have, let me see if we have patch AMSI over here. I'm not sure whether I have added that. No, I'll probably, patch AMSI is also exactly similar. Instead of calling ETW event write, you just you simply just load up AMSI scan buffer over here from amsi.dll and patch that across. Over here, we are patching ETWTI. If we are successful, we are simply returning an error. Sorry, we're simply returning true. Currently, I'm not patching it to show you how it looks like in memory, and then I will patch it and show you how the patched version looks like. Now, these portions are more or less the same. We are initializing variants and objects over here, and they're nothing but where we'll be copying our array. However, you can see that things look a bit different from our previous code over here. We're initializing our object string variant that we have and our retval variant where we will be fetching our return value. We are initializing it with null. We are specifying that this args variant is going to be an array which contains bstr. Bstr is of data type wcar. So we are simply saying that it's an array of wcar type over here. We're extracting whatever was the argument count supplied by the user. We're seeing that I can say I'm doing argc -1 because let's say the user supplied 3 arguments over here. By default, the argc count will be 4 because the first value will be of the executable itself, and we're only going to supply whatever the user supplies over here, and we're going to supply only those values directly to our C# code, whatever the seatbelt request. So we're subtracting -1 so as to remove the argv0, that is our p itself, from this argument count. Before we get started, sending that over here to the argbound to specify how many values are there inside this argbound array that we have. We create a safe vector and we're specifying that this will contain data type of bstr. Bstr, if I do a control click, you can see it is basically of the enum value 8. You have different values. Bstr is nothing but something similar to your wcar array that we have. So in short, what we are simply doing over here is we are saying that we are going to initialize an array of wcar type. We can see we have specified that it's going to contain one value over here, a total of 2 indexes. We are looping through the number of arguments that we have. We are going to copy all of this value, how many values that we have. We replace that with the idx value. Idx is again our long unsigned integer that we have. We're going to copy, we're going to allocate some memory for our argument, because right now we are going to convert it from our argv that we have received to a bstr. Whenever you allocate string via sysalloc, you can see that it returns bstr. So in short, take whatever argument we have, convert that to wcar to bstr, that's your b string, copy that in the idx0, and then copy that value to your array value that you have, a pointer to an array which we initialized over here. Now this is very much required because we need a variant array which will be letting later on pass on to as a parameter to our code. Finally, we have params bound over here. We are going to create another params bound. We are going to copy our arguments that we have into this params bound that we have and initialize it with 0, which means this whole argument array that we have, we're going to pass it on as a single array to our value that we have, to our C# code. This simply means it will be something like this, for example. Sorry, my bad. Let me comment it out. It will be your params that you have will contain an array which contains an array for, let's say you specify system or user, whatever argument you specify. So this value that we have, that is going to be our args value that we have over here. This is what our args is. And this value that we have is what we are going to copy it, because we're going to pass on a single argument to our function, to our whatever the entry point of this would be, that is main, invoke ps, whatever that would be, and we're passing out a single function. Once you pass it across to the entry point of your seat belt, let me go back to this. You can see it's an array. Now this array will be only this value. So you pass on this whole value, but when it passes on, it will actually extract only the value that is inside this, and it will pass only the inside value. We are doing this because if we only pass on something like, let's say, this over here, if you only pass on something like this, it will try to extract only these values and not the whole array, and only try to pass on the value over here to our seatbelt, which will eventually lead to a crash. You don't want that to happen because it's an array. So we send it an array which contains an array over here, because these values, the params value, will be extracted before actually sending out the inside array values that we have. The remaining portions are the same. Copy the seatbelt.exe over here, find the version. I have another small piece of code here, which before executing that C# code, it loops to the C# code and tries to extract this value. This is something that I directly copy pasted from Stack Overflow. Your Stack Overflow, I will probably have to search for that link. So according to this, this is basically for your .NET 4, and this is the signature for your .NET 2. This is always going to be static for your 2 and v4 over here. So we're just going to find the signature. If our assembly contains the signature for .NET 4, we will return true, else it will return false in this specific case. If it's false, it means it's going to be a .NET v2 type. So we're going to find what version it has. If it's .NET version 2, we will go ahead and load that up over here by printing it on screen. Create host does the same thing. Start the CLR, get the default app domain, query the interface, load 3, and instead of calling invoke PS like we did earlier, we are dynamically calling get entry point. This will extract whatever entry point you have and run it. The only concern over here is that it should only accept the value over here as string array. If instead of this, let's say for example, I will copy this over here. If instead of this we have something like, for example, just a single string argument, our code will not work. It needs to be a string array, because that's what we are going to supply over here. As you can see, params over here, which is also a string array, which you can see that we created over here. That is what we are going to pass across. So which means that this has to be in this specific format itself. We're dynamically extracting the entry point, and we're calling invoke 3, and you can see that's all that we do. We don't even need invoke method over here. Invoke method is specifically for our previous code. As you're calling invoke 3 is a part of our method itself. So you don't even actually need this code. If I comment this out, this should still not be an issue here. As you can see, because this code was specifically for your PowerShell code itself to call the invoke method over there. Right now we are just directly getting the entry point and calling it. And we are not calling that previous code over here because that previous code was simply for passing our arguments and passing it across. We're already doing that over here in our current code. So we don't need to do any of this. So we will just compile this and we will go back here inside our debug folder. Sorry, it should be at the outside. Yeah, this folder, AMD, C sharp, and it should run seatbelt as you can see over here. I've added a sleep at the end. So let me just show you how this looks like in memory. You can see the .NET assembly is the name of the seatbelt. That's because we have our namespace over here, and this is captured by etw ti that you have over here. However, if I go and let's say if I enable this, click build, and if we go back and run this, let's see how it looks like right now. You can see it's stuck at loading dot. I think it exited. Let me add a bit more values to sleep here. Sorry, I think I hit enter, my bad. Let me go back. You can see it's stuck at loading assemblies over here. There's no response that you would eventually get. And the process also exited. I should probably add, let's say, sleep over here instead of get char. I think the moment I open this, it is sending probably some argument over there. The moment I double click on it, yeah, I think it's crashing, and that's totally understandable. The reason it is crashing is because we have passed etw, and the moment we'll have to load it, it's trying to, you can see that it's trying to call the etw tracing session. Since we have already passed it, we are simply returning, so there won't be any .NET assemblies loaded over here by default. And if you want to take a look at how this looks like, let me go back. Let's see how etw patching looks like. I will remove this portion of the code over here. Click build, or let me do that. I will just actually let it run over here so that we can actually see how it looks like. Control command compile, go to our debugger, OTD day2, sorry, not day2, it's outside, debug C sharp loader. Sorry, did I compile it as a X? Oh, I think it by default compiled it as let me see, I should be able to compile it over here as well. Let me see if it runs. Yeah, and let me load it. Minecraft. Uh, OTD C sharp x64 debug, and yes. So if you go, okay, I think I ran the incorrect P here. So let me go back to x64 and first verify whether our code is running. Yes, our code is running. And let's see, this is our console over here. I'll let it run. You can see we have an exception, which is totally fine. This exception was raised by kernel-based.dll, which means there's nothing to worry about, not an exception on our code. I will let it to run another C++ exception, which is totally fine. I'll let it run and another exception. These are fine. These are loaded by your clr.dlls, so you don't need to worry about it. And you can see that it has successfully run. If I go here, search for ntdll, sorry, my bad, ntdll, etw event write, I will add a lock here. Right click, follow in disassembler, you can see the original values. However, if I go here and uncomment this portion, compile it again, and try to run it, it should be overwritten with C3. Let me run it, and let me run it. Right click, follow in disassembler. You can see it's overwritten with C3, which is basically simply return. And that's because we added a ret over here inside our patch etw. Sorry. You can see we added a C3 and 0000, which is what you see, C30000. Does that make sense? Is this clear right now? Okay, so that's how you load the C sharp code in memory. Now, here's the funny thing. If you want to load the C sharp code into a target process, right? You have to first load your code that you have, this code, which loads your C sharp code. Yes, virtual protect might be hooked over here. Actually, let me show you something very funny. Microsoft is actually stupid, so I think you might already know about it. You don't even need to do all of this. Just go here and call this over here. I think even that should work without changing the permission. I think it should work if I'm not wrong. Let's see. Right, run it, and if you go here, it should still be overwritten. As you can see over here, we are not even calling virtual protect anymore. Reason for that is because when you call write process memory, it will take that region. If it is not writable, it will convert that. Yes, it will convert that to not RWX. It will convert RX to RW. Write it, convert RW back to RX. Microsoft is stupid. So that's what you are seeing over here. Yes, you also have to make sure that you don't call virtual protect. Use NT-protect virtual memory with indirect syscall. That should help you out most of the time, and that you should just be able to override that with whatever values that you need. Shouldn't be an issue. I haven't seen anyone detecting any of these detections, at least till now. And make sure you restore the original. Over here I'm not backing up the original instruction. It's a good idea to back up the instruction, write the process memory, then restore the original instructions back over here, so that anyone who takes a look at it, they do not get suspicious at the point go itself. So any doubts, any queries, any questions still over here onto this specific part? To load this into remote process, we have to write a loader. Yes, that is correct. That is the reason why I showed the reflective DLL earlier. So whatever reflective DLL you write of your own, either the one that I showed you in the morning or maybe your custom one, you inside that reflective loader, copy this piece of code. So in short, what you're doing is you have your payload loads the reflective DLL into a target process. That reflective DLL runs this code that you have, and then it loads your C sharp code, which runs and returns you the output. So it's a basically multi-loader kind of situation. So, any other questions? Anything else? This was actually supposed to be a task, but I think it might have been a bit complicated to convert this piece of code that we have over here. This is probably the most confusing part of the whole code. I think the loading part is probably easier. It's just converting C to C++ is a pain. Yes, I totally feel your situation over here. Not a problem. So, yes, I think that brings us back to the final part. This is basically the two tasks that you can probably try it out on your own to achieve this. The C sharp loader has to be a DLL for reflective DLL. Uh, by C sharp loader, do you mean the loader that we added over here? No, sorry, not this part. This one, right? This one has to be a reflective DLL. Yes. Yes. So just copy all of this into your DLL main function, and that should be more than enough most of the time. But yeah, obviously what the code that I'm showing you over here is not OPSEC safe. There's a lot of things that you can do to improve this code, which I have not gone into the depths of, because that will again, it is a different catch altogether. First of the things, I have not patched AMSI. Make sure you patch AMSI as well, because that still uses string comparison even on your .NET code. The second thing apart from that is obviously remove whatever strings that you see over here. The third thing over here is use NT API or an indirect syscall instead of something like this to actually call it. The third portion over here would be I think the remaining portion shouldn't be an issue. I think I'm using a default. Yeah, I'm basically using a get default domain here. There should be another function over here to create an app domain. Let me just see. Inside the core runtime, there should be a function called as, yeah, create domain. So you can see this create domain call inside iCore runtime host. Over here, we directly extracted the default domain that you see. So the default or app domains can be caught. Don't do that. Use your custom app domain by calling create domain. You can see a friendly name over here. That is all that is required. So it's as simple as this, not really something that is complicated. So create a default app domain. The remaining portions should basically be the same over here apart from that. So just a few things. And yes, always make sure using the technique that I showed you in the morning where you can walk through the PEB and find the DLLs loaded. What I usually do during my red team engagement is in my C2 that I wrote, I have a list modules functionality, which basically lists modules from PEB of remote processes. So I can just specify list module space PID. It will go and enumerate all processes and return me a list of DLLs loaded into the target process. You can use something like that to enumerate all the exes that are currently running already that are running into the current system. Find which exes already have your clr.dll loaded, and instead of calling load library over here, try to sorry, not over here, calling load library on ms query, because even this is detected by some edrs. The edrs will check whether the load library for ms query is coming from a user allocated rx region, so even that can be a catch. So what I did with my current release that I just did a few days back, I'm first checking whether this already exists into the PEB. If this is already existing, I don't need to call load library. I will just extract its handle and use it altogether. So basically a bunch of things that you can do to improve over here. Yeah, it's a lot of things, but yes, so OPSEC is also an important part. So that can be a bit complicated at times. So yes, I think that brings us back to the end of the current workshop today. For today. Yeah. So any questions, any doubts, anything else on the C sharp part? And I understand that this might not be altogether easy because C sharp loading was never meant to be easy. It is a bit complicated at times, so it will require a bit of practice and everything. But in short, you should be able to just perform an XXD, copy Rubius or whatever you require over here, and everything should work flawlessly. So any questions, queries, or anything else over here? No doubts, no questions. Yes, we will have a few more. Tomorrow and day after tomorrow, we will be writing some really, yes, I think I understand because even when I learned this for the first time, I spent a lot of days trying to restructure the code, understand it, removing a lot of garbage code, and so on. That is something that will obviously be a part of any workshop. And apart from that, I think, yeah, tomorrow and day after tomorrow, we won't be focusing a lot on PEB. We will be focusing more on writing other tools in C itself. I'm not a fan of C++ again, and you can see this whole code is written in C++. I had to rearrange this whole code to uh, write this whole code in assembly myself when I was implementing a tool called as Sharp Inline in my BruteRTL. And I could not, for the pain of it, I had to write this whole portion in assembly. So it was very painful for me to make it a bit more portion independent because I cannot have strings like these into memory that you see over here. So but yes, that's the fun part about writing a C2. So yes, I think that will be all from my end. So any questions, queries, anything else for the day? Okay, that brings us to the end of the workshop for today. So I will leave you guys to it and you can continue. If possible, try to use other C sharp tools, take a look at it, modify these values, see how it looks like in memory, both in process hacker as well as because process hacker can clearly show you how it will also look like to your EDRs as well, the ETW part. And you should be able to bypass them by just patching the AMSI and ETW in this case. So that will be all from my end. And if there are no more doubts, I will see you guys tomorrow with the remaining part of the code. Thanks, guys. Cheers. Bye. Bye, everyone. I'll see you guys tomorrow.